Hello friends, I am Vijan Valivaril. All are welcome to my YouTube channel. In this session 17 video, we are going to see how our train is stalled in a gradient, that is a steep gradient. Our train is now proceeding from station W to station X, and the block section between station W and station X is having gradients. And in the next diagram, we will see what is meant by a gradient and how these gradients are named, etc., and how our train is affected in such a gradient. Okay, let us go to the diagram. Now our train is moving from station W to station X. Here it is the station W and here it is the station X. In between this is the block section. This is downline and here this is the upline. Now our train has left station W and it is proceeding towards station X. Here this upline is having gradients. Now what is meant by gradients? While we are traveling by car or bus, we can see that the road at times is rising and at times it is falling or it is going down, and again the road will be going in a plane surface. So there will be rising and falling and also level area through which the road is laid. In the same way, the track will also be laid according to the topography of the land. Suppose there is a small hill here, then the track will be laid to cover this hill, and after the hill it will again go in a plain area. So here this rising of this track we will call rising gradient. Here we can see it is falling, so here it is a falling gradient. Here the downline, no problem, it is in a plane surface, but here the upline is rising and falling, and also in certain areas it is in plane. Now we will have this portion of this upline track separately to see how this gradient is named. Normally the gradients will be named 1 in 400 or 1 in 260 or 1 in 100, like that. Here this is the upline, here this is downline, Now this is the section between, here the station is W and here the station is X. This is the portion of the track we have now taken to see how these gradients are named. So here the track is laid like this over the hill. Now from this plane surface, when the track is laid 260 meters, it has gone up 1 meter high from this plane surface. Then it is called 1 in 260 rising. This I have marked is 1 meter high. 1 meter high from the plane surface. Suppose this track is laid from here it is going like this. The track is going like this. So here we can see the track is 1 meter high from here. Here from this place the track is not 1 meter height. Whereas from this area, from this spot, the track is 1 meter high. So what will be the distance here? Suppose you take it as 400 meters. From this plain area to this 1 meter spot, it is 400 meters. Then we will say it is 1 in 400 rising gradient. Now let us take from here, it is 1 meter high. From this plain area, the track is laid. Now track is going like this. From this spot up to here, the distance is say 600 meters. So we can say this gradient, this track gradient is 1 in 600 rising. Here I have drawn 3 imaginary tracks. From the plane surface, when the track is laid and when it reaches 260 meters, it is 1 meter high from the plane surface. Then it is called 1 in 260 rising. When the track is laid 400 meters, then only it is have the height of 1 meter from the plane surface. Then it is called 1 in 400 rising. Whereas here we can see only when 600 meter track is laid, then only it is rising from the plain ground to 1 meter height. Then it is called 1 in 600 rising. Now we will see comparatively which is steeper gradient. Now you see this 1 in 260 gradient is sharper compared to 1 in 400. Or we can say 1 in 260 gradient is steeper than this 1 in 400 gradient. And 1 in 400 gradient is steeper than 1 in 600 gradient. Here we can see 1 in 260 rising is the steepest gradient of all these three gradients. Whereas 1 in 400 rising is less steeper and 1 in 600 rising is actually flatter. Compared to the other two gradients, this is flatter, 1 in 600. A gradient is called rising or falling according to the train traffic. Here the train is going towards this direction, so we can say this is a rising gradient. Suppose the train is coming in the other direction towards this direction, then we can call this is falling gradient for the train. Here we can see for this gradient is falling gradient for this train. So the gradient is called according to the movement of the train. These gradients play very important role in three areas, that is in case of shunting operations, it is, and also securing of vehicles, and also it plays an important role in loading of goods wagons. Now we will see what is the problem with the shunting. Suppose this gradient is in the station yard. We want to shunt a train. When this train is taken like this towards this area, there is a chance for these wagons getting broken from this coupling and running away into this line. Also, this engine will have very much strain when it is taking all these loads towards this uphill or towards this 1 in 260 steeper gradient. When shunting is undertaken in such a gradient, that is a gradient which is 1 in 400 rising. That is not 1 in 260, it is 1 in 400 rising. That is, even if it is a gradient like this, a lesser gradient, here 1 in 260 is a steeper gradient, 1 in 400 is a lesser gradient. Still, even when shunting operation is undertaken in 1 in 400 gradient, an engine should be attached at the falling side if this line is not isolated. Though the rule does not say that the shunting engine should be at the falling side in such gradients, it is safe to have the shunting engine at the falling side. Otherwise, there is a chance of this getting broken, the coupling getting broken and vehicles running away from the yard. So this is a problem with the shunting. At stations, the coaches or wagons or even the locos, when they are not used, it should be secured properly. Secured means it should not run away from the station. If there happens to be a heavy wind, even there happens to be a jerking, when other trains are moving in the track, there will be some jerk, and because of that jerk also, there is a chance of these wagons getting moved. So in order to prevent this, the wagons will be properly secured at the station. We will learn this securing etc. later. So this securing is also a problem at such gradients, because it should be very what is called carefully secured. Otherwise there is a chance of this train or even the wagons or even the coaches which is kept at the station yard may run away. So that securing is also a problem when there is a gradient. Then loading. Suppose this is a sharp gradient. Here it is a 1 in 260 gradient and a goods train is hauling heavy tonnage. In that case, this engine may not be in a position to hold this much tonnage. In that case, One engine is also to be attached in the rear side and it will push the load, and so this train will move. Suppose such steep gradients are there in this section, an engine is also to be attached to this train either in the front or in the rear to overcome this gradient. So that is also a problem, that is we must have an extra engine to transport these goods. So these are the three problems normally connected with the gradients. Now we have just seen that this gradient, this applied gradient is 1 in 260, 1 in 260 gradient. Now our train has left station W and it is proceeding to station X. Stations will also be having gradient. Normally stations will be having a maximum gradient of 1 in 400. 1 in 400. Station yard will be normally having a maximum gradient of 1 in 400, because as I told you earlier, if it is a heavy gradient, if it is a steeper gradient like 1 in 260 like that, then it will be very difficult for shunting as well as stabling and securing the vehicles. There is a very chance, always there is a chance that vehicles will run away to the section. So normally the station yards will be having 1 in 400 or less gradient. At the same time, it must have a minimum gradient of 1 in 1000. Station yards will be having a minimum gradient of 1 in 1000, because when there is a rain or when there is storm water, wastewater, that is sewage water will be there at the station. In order to have a free flow of this water, the station will be having a minimum gradient of 1 in 1000. Now we will come back to our train. Our train has left here, left station W, and it is proceeding, and it is here in this gradient. Our train is trying to negotiate this 1 in 260 gradient and it is trying to move, but the train got stalled there, it got stopped there, because its wheels, that is the wheels of the engine, began to slip. That is wheel slipping, we will call it wheel slipping. What is meant by this wheel slipping? You might have experienced that when car or bus, when the wheel is what is called plunged in mud or in slush, what happens? The wheel alone will rotate, the bus will not be in a position to move forward, or the car will not move forward, only the front wheels will rotate. The car wheel is moving forward by pushing the land backward. When the land is hard, then only the wheel can push it backward. Suppose the land is slush, or the land area is slushy, or it is muddy, what happens? That grip will not be there and the wheel alone will rotate. The same thing is happening here. At this time there was drizzling, a slight rain was there, and because of that the rails have got wet and also the wheels also got wet. When the rails got wet, there is naturally wheel slipping will be there, that is the wheel will not get grip with the rail. Now what the loco pilot will do? In every engine, in the front there will be two boxes which is called sander, that is sand boxes, which is filled with the dry sand, and this dry sand will be dropped through a tube on the rails. You know the track is having two rails. On both rails this sander will drop sand, dry sand, so that the sand between this rail and wheel will give sufficient grip. Now the loco pilot has operated the sander and the sand has fallen on the rails. Now the loco pilot tried to move forward. Unfortunately, still he could not move forward. The wheel slipping continued, he could not move forward. Now what is to be done? Now he can try one thing, that is to back the train to the plain area and try to move with full throttle. So for that he will consult the guard. Without consulting the guard, without his permission, he should not move the train backward. The station as well as in the midsection, anywhere, without the permission of the guard, the train should not be backed. So he consults the guard. When the train is stopped here, normally he will call the guard to the front by giving a whistle code of too long, too short. But nowadays they are having walkie-talkie and they will contact through walkie-talkie, and the guard need not go to the engine side. With the consent of the guard, the loco pilot will back the train to the plain area. Thereafter, he will, with the full throttle, he will go uphill. But here again, the train came to a stop and the wheel began to slip. He can't move forward. Now the loco pilot should not accelerate again. The slipping wheel will create a dent in the rail. In that case, the rail itself is to be changed. So in order to avoid that, if he is unable to move further, the loco pilot will stop the train. He will not try further. Now like this wheel slipping, there is another phenomena called wheel skidding. Wheel skidding. When wheel skidding is there, a pair of wheels will not move, whereas other wheels will move. So the train will move forward, but a pair of wheels will remain there static without rotating. When it is hauled along this track, the portion which is touching the rail will be worn out. So this wheel will develop a flat portion here. In such cases, we are calling it is a flat tire. The wheel is having flat tire. Instead of having a perfect round, here this portion will be flattened. When we are seeing a train, when it is having this thud voice, we can understand that wheel is having flat tire. The jamming of the wheel can be due to brake binding also. When the brake is applied and when it is released, if the brake blocks are remaining there itself without releasing the wheel, then the wheel will not rotate. And this brake binding case also, the wheel will be getting this. This wheel skidding is not restricted to this engine. Wagons and coaches, all these wheels can have this wheel skidding. Now let us come back to our train, which is now stranded here due to wheel slipping. Loco pilot understands that he cannot move further. He wants support of one engine, one loco. Now when it is almost certain that the train cannot move without the assistance of a loco, or the train is to be backed to the station W, the guard contacts the controller. Guard is having portable telephone with him, and through that he can contact the controller. Nowadays it is easier to seek help through RE telephone. Anyhow, the controller is contacted and he says that a loco will be arranged from station W to help this train, so that it can be attached at the rear and the train can be pushed towards station X. Let us take that this train which is stranded is very near to station W. In that case, there is also a possibility that the controller will tell the guard to back the train to station W. If guard could not contact the controller or anybody else, guard can consult the loco pilot, and if they decide that the train can be backed to station W, they can definitely back. Suppose this train is going to be backed to station W, how it is to be done? Let us see. See, if possible, the guard should inform the station master W that his train is going to be backed. Suppose he is not in a position to inform the station master W, still the guard can back the train. Now while backing the train, where he should come and stop? The train should stop short of the advanced starter of the subdirection, or it should stop short of the home signal of the down direction, whichever comes first. He should come and stop at the first signal, that is, here is double line. here is advanced starter towards this direction, here it is home signal towards this direction, that is in downline. The first signal they will be approaching will be the home signal of the down direction, because from this home signal towards this there should be a minimum 180 meters, whereas here this advanced starter will be very near to this point. So normally this train will be approaching the home signal first, though it is in the opposite line or it is in the down line. This train will come and stop just opposite this home signal. Here it will come and stop. Now the guard will come out and he will go to the station W and inform the matter. Now the station master will issue a memo in duplicate to be served to the loco pilot of this train to back the train to the station. In the memo, the station master will clearly state where the train is going to be received. Here it is in the common loop, maybe in the common loop the train will be received. Anyhow, before giving this memo, before handing over this memo to the station staff to hand over this loco pilot, it should be ensured that all these points are set in favorable for the train and clamped and padlocked, because there is no signal governing this movement of this train. So this advanced starter is towards this direction, towards the up direction, so there is no signals governing this movement. So all these points over which the train is to move, here this one, here, all these points should be set, clamped and padlocked in favor of this train. Station staff will be taking the memo to the loco pilot and getting his signature in the duplicate. The train will be piloted by the traffic staff to the station. Now the train will move very slowly towards this direction. While the train is moved towards this direction, suppose this point is not set favorable for the train. That is, this point is set for this line. We are calling this point as trailing point. We have previously seen what is trailing point and facing point. Here this point is trailing point. Trailing point. Now suppose this point leading to this siding is not set favorable for this train, means when the train is moving here it will damage this point. Anyhow, the train will not derail because there is only one path from here, so this train will move towards this direction, but it will damage the points here. Here the train will not derail, but the point will be damaged, and this kind of accident is called trail through accident. The loco pilot understands that the train has trailed through the point. On seeing that the point is trailed through, his impulse will be to back the train, but it should not be done. If he backs the train will derail. If suppose the engine just passed this point and stopped trailing through this point, it is stopped. But if it is backed, means the engine will derail. In a trailed through point, the loco pilot must not back the train. Okay, see, the backing of this train will have two problems. One, it should be ensured that all these points are to be set, clamped and padlocked by the station master, and it will be consuming very much time. There is another problem while backing this train. See, in double line, a shunting beyond this advanced starter is normally called a block forward. Block forward can be done only if the block section is clear of trains. See, our train is now here. Definitely the rule does not permit block forward in this section because our train is here. So unless the block section is clear of trains, block forward should not be resorted to by the station master at W. But it is also stated that under special instructions, this shunting may be permitted if intimation has been received that the train has arrived at the block station in advance. In short, block forward is not permitted when the block section is occupied. Since that be the case, interlocking should have been there between the LSS key and the block instrument. Because for the block forward movement, the normal authority given to the shunter is LSS key plus one memo called T bar 806. LSS key is a key extracted from the station. A Hepper's instrument will be there at the station. From that a key will be extracted and it will be given to the loco pilot. So these two are to be given as authority to block forward. Now the LSS key can be extracted from the instrument when the block section is occupied. That means when the block section is occupied, the station master can extract this LSS key, and also if he gives T bar 806 memo, then the shunting can be undertaken when the section is occupied. So there is a danger that when we are backing our train here without the knowledge of the station master W, the station master W can send a train towards this direction with the LSS key and T bar 806. A shunting operation, a block forward movement can be given. We are backing the train, another train coming in this direction. Anyhow, this backing of the train to the station is always risky. Because of all this, it is not desirable to back the train to the station. Anyhow, our train is not going to be backed. Our train will get an engine from station W, and on attaching that, our train will go. Okay, we will see that later, how our train is going to move from here. Now our train is stranded in the block section between W and X, and we are expecting an engine from station W to help our train, and we will see how this train is moving further from this spot in our next video. Okay.